So I'm Trevett. I'm the president of the Khronos Group, and I've been working with Fabrice from Mobility, who's the COLLADA working group chair. So we're going to share this presentation. So I'm going to start out with some PowerPoint, an update about what Khronos has been doing with COLLADA since the last meetup we had, which was at GDC. And then Fabrice is going to start us off with some demos, and then we actually have a number of demos that are going to be coming up during the BOF, showing their work with COLLADA, and then we're going to make sure that we have time at the end for any questions and discussions, because we want to get feedback from the community on what we're doing on COLLADA, and is it the right thing for you guys. So let me go through the PowerPoint. COLLADA is the one standard that Khronos manages that isn't an API, it's an XML schema for 3D assets. And we have pretty good COLLADA momentum in the industry. In many places, many key players are using COLLADA. Apple has always been a strong supporter of COLLADA, used COLLADA in macOS Lion and iBooks. And in Mountain Lion, now SceneKit framework for creating and displaying 3D scenes is using COLLADA. And I think we're going to have some demos on that, right?
Yes,
yes.
At the end.
At the end. Google has used COLLADA in KML. Adobe uses COLLADA as an input format for Creative Suite. And we've had a long-term relationship with the CAD community through Automation ML. That's a group that's creating standards for putting together factories that use robotic manufacturing lines, and they use COLLADA to visualize how all the robots in the factory are going to interoperate. But we have some significant news for the COLLADA community. As of a few days ago, COLLADA is now an official ISO standard. So SC4 and TC184 has selected COLLADA as an official ISO standard for CAD and DCC data. This is the blurb from the front of that standard. This came from a direct request from the CAD industry, primarily. Is that right, Remi? Yeah. Because they wanted to have the confidence that COLLADA was there for the long term. It's going to be an ISO standard for approval, and now it is an ISO standard, and it's also going to be around for many years, hopefully giving people in the industry the confidence to invest in the standard and to use it as a long-term archival format. So I think it's awesome news for everyone involved, and thanks to Remi and to Mark who helped push this through with the ISO guys. Quite some effort to make that happen. So at the meetup at GDC in San Francisco, we had a good discussion with the community, and one of the key things that we discussed there was to put an increasing amount of COLLADA-related resources into open source, and actually not just an open source, so actually quite a strong request from the community there to actually use GitHub as the source repository. That seems to be the zeitgeist right now, to use GitHub. So since March, and this is thanks to the folks in the working group and Fabrice, we've managed to get the open COLLADA open source importer-exporter now is uploaded to GitHub and is available, of course, for everyone to use under a good open source license. Also, we had a request at GDC that we put the full conformance test suite onto GitHub and to make it free of charge, available to anyone in the community who wanted to use it to test that their import-export capability was fully conformant. And this is a screenshot. It's actually a pretty sophisticated tool. So the two together mean, of course, that a tools vendor can now take a pretty full-featured importer-exporter Open COLLADA. It's getting pretty good reviews. Many people think it's one of the best importer-exporters out there. Integrated into their tool and test it without needing any licenses or fees to anyone. We hope that this will encourage tools vendors to create high-quality COLLADA import-export capability. We do have a list of known bugs in Open COLLADA. They're not architectural bugs, they're annoying, and we want to get them fixed as quickly as we can. So the Khronos board has allocated $20,000 US RFQ, a project to someone in the community to work through that bug list and to bring Open COLLADA up to a baseline of debug functionality that we can use to continue to engage with the community. So there's a RFQ, a request for quotations, which basically is more detail about what the bugs are and what we would like someone to do for that 20K. And if you're interested, you can download the RFQ at that URL. These slides will be posted on Khronos.org by the end of the day. If you don't have time to write down that URL, or just come and talk to me or Fabrice, or email me and Fabrice, and we'll be glad to give you more details on how to engage and put in a bid for that 20K if you'd like to. We're aiming for vendor selection in September, and we'd like to get that going in September and hopefully get closure probably around the end of the year. There's been quite a bit of discussion at the Web3D conference earlier in the week about a transmission standard. So we thought we'd just, there are some new faces here, but I don't think we're at Web3D. So just to talk about that, because it is kind of closely related to COLLADA. I think it is relevant to the COLLADA community. So there's been some discussion around various groups, Web3D, MPEG, Khronos, COLLADA and WebGL around the potential need in the industry for a transmission standard. The basic realization is the other media types have a compressed standard, so why don't we? Why doesn't the 3D industry have something the equivalent of MP3 for music, or H.264 for video, or just the JPEG for images? In each of those cases, once a well-defined codec becomes pervasively available, it creates new ecosystem and marketing opportunities. I think the most obvious one perhaps is Napster, which was basically triggered once everyone had MP3 decode capability. But YouTube is basically being enabled by H.264. And of course, pictures on the internet have been reliant on a good codec for a while. So, but we don't have anything for 3D. And there's probably a good reason for that. A 3D codec is probably going to be a lot more complex, a lot more challenging to define. But that doesn't mean that there's not an opportunity for the 3D community if we were able to get something defined. And there's actually been quite a lot of work already. MPEG have had compression technology for meshes and animations for almost 10 years. It hasn't had much adoption in the industry. One reason might be that MPEG haven't clarified whether or not they will be royalty-free, but they have actually now clarified that those parts of the MPEG framework potentially could be made available royalty-free if you can find a way to build it into a standalone standard. Google has been doing work with WebGL, the Google Body project, included some interesting compression techniques. We're going to talk about COLLADA to JSON. That's Fabrice's project, where we're converting COLLADA into a JSON representation, but with the assets in a separate blob. So that's kind of compatible to being able to compress that blob at some point. Again, earlier in the week, at the Web3D co-located meeting here, there are a series of actually quite interesting papers about people working on various ways of compressing meshes and other assets So there's a lot of activity going on, and there's an opportunity perhaps for the community to come together and try and figure this out in a more directive way. I mean, there's other stuff too that can be, I think, leveraged and is really helpful to this whole concept. So, for example, the work that Remi's doing with the RESTful 3D, making a 3D into a web service, so you can have a client requesting with some depth and complexity precisely what it wants from the server. And that gives you a choice of compression or proxy or streaming options. That means we don't have to bake everything into a low-level compression standard. We can just let a potential compression standard focus on compression and let something like REST take care of all of the higher-level negotiations between client and server. So basically lots of stuff going on. And this is, the idea is that you have a codec, so you could encode 3D assets and then decode at the client, separating the assets from the Siggraph. You use something like JSON or something else, depending on what you wanted to do with the assets. Perhaps using something like a RESTful API to have the two ends of the pipeline cooperating. But it is going to be a challenge. 3D is not trivial to compress. There are probably going to be lots of different ways of compressing 3D assets for different types of data sets and different applications. But it seems like a potentially fruitful discussion. And because we have multiple organizations that are already working on this and have expressed an interest, we've been trying to figure a way to have multiple standard organizations cooperating together on this particular topic, because it reaches out into many different groups. So to kick that discussion off, Khronos has drafted a draft MOU, which is not that complex, suggesting how we could have 3 or more standards organizations cooperating together. And in essence, it's very simple. All the SDOs, that's the standard defining organizations that want to participate, would sign an MOU. And we would minimize the interface area between the different standards organizations. We're just trying to get 2 standards organizations to mesh all the details of their IP framework down to the last legal clause. That's pretty well impossible to do. But we can, I think, come together in a working group with a minimal set of commitments to each other. And that minimal set of commitments would be, we're going to work in good faith together to create a joint specification. If and when we get to that joint specification that we all agree to, we're going to give each other copyright rights so we can all distribute it. And we're going to commit that we can manage our intellectual property frameworks to make this standard royalty free. That's all we would have to agree to. And you would be committing that you can manage your own processes and your own membership in an appropriate way under your own bylaws to meet those commitments. So if we can get 1 or more organizations to join up, we can have then a working group where any member from any of those organizations would come. It would just be like a normal working group in terms of logistics. Inside any of those organizations, a group of people coming together to solve a problem. Once that liaison working group creates a specification, it will be sent back to all the participating SDOs, and they will ratify it under their own framework. And but they will ratify it in a way that it was royalty free and available to the other SDOs to distribute as well. And then once it's ratified, all the SDOs will be able to distribute it to them. So it's I think it's an interesting way. And I think this is a way perhaps to build industry momentum. But this is one of the things we want feedback on. And at the end we'll have a FAQ, or after we come down off this thing, we can talk on this one-on-one. Interested in people's feedback, particularly if you're in an organisation that might be interested to participate in such a liaison. So that's it. So I'm going to hand over to Fabrice, who will run this show.
So as the last meetup, we had a number of interesting discussion to bring traction for COLLADA, and one of the discussion was about all the open sourcing that we've done with GitHub, with Open COLLADA and the CTS, but the other subject was clearly how to bridge the gap between COLLADA and WebGL. Because there is a lot of common needs for all WebGL developers. You have a clear place for COLLADA with, as an intermediate format, but it's not designed to be straight given to WebGL regarding the GPU. You have to modify the data. You have to do some transformation, and every WebGL developer has to implement this transformation. So there are a number of use cases where you can do these transformations, like unifying the index buffers, creating the shader, and also splitting the bases. There is a number of use cases where you can do that before the runtime at the conversion. So why not having a final format for WebGL? So it's more a WebGL transmission format than COLLADA as JSON. It has to be thought as a way to take what's based with COLLADA regarding all the fact that you can hold all the data, and you can convert that as a final format for WebGL. So it makes a clear ecosystem. And the big advice here is to not try to reinvent COLLADA with JSON. There is a small demo after, so you can see more concretely how it is implemented. And there is some very nice side effect of doing a JSON with a blob on the side. That way you can just request the data on demand and get very quickly what's usually cheap, which is a Siggraph, and what's very expensive, which are the vertices and the indices. You can get them more lazily, and you can do things like progressive loading, but you can also add compression, any compression on top of that. You have also an implementation, which is COLLADA to JSON. And I will do a little demo. That's good, just after this talk. So let me switch. Okay, so this model has 1,500 meshes. It's lots of small pieces. And we can reduce the number of buffers that we match together and the number of concurrent requests. So we simulate a low bandwidth. And we can do that because we don't have to load everything like this COLLADA. Here it's converted for WebGL, so everything is straight given to the GPU, but also you can do range requests exactly the way you want. So let's restart. But since you have the JSON and already the Siggraph, you can also show the bounded boxes very soon and show all the progress. So if I had a very low bandwidth, I could still get a pretty good idea of how looks my model. So that's COLLADA to JSON. And the obvious thing that's missing here is the compression. Nothing presented to do it. It will be added very soon. And also, I will write a paper about it and explain a bit more about the format so that people can adapt. Okay. So I will let, also there is a nice demo done by Brandon that will be shown at the WebGL session using that format. I will let Remi take over. Is there any demo?
Alright, so I had this idea to do an exporter for this tool in Unity. So it's kind of a crazy idea because Unity is an engine where you actually import the things and then you clean up your data, add scripts, and create a game. And pretty much don't export from tools like that, you create a game out of it. But I thought that it's actually a very nice tool for creating game content. And there is no reason at all why you can't keep going in the toolchain and use that as part of any of the tools in your toolchain to create your content. So I thought it was a big missing piece of Unity, so I decided to start looking into it. And I want to give a big thank you to Rita Kursky, who helped me to actually decide to make it a real package and upload it to the Unity asset store, which is now actually from like a couple of days now available at this URL. So if you click there, you're gonna get access to the asset store, and then you can install it into Unity and then start exploring COLLADA. As soon as I know where to put it, there's so many lawyers. Well, so in the map though, because I'm not a Mac user. Alright, so the way it works is very simple. There you go. So here, okay, so that's Unity. So you load your game in Unity, and you have your entire scene, and then you can click on one or several objects that you want to export, and then you just I'm trying to click. It doesn't do anything. Hello. Maybe it's because I'm not there you go. So you click on that door here, and for example, and then I just export it. And doing a demo of an explorer is not very interesting, but what's interesting is the different options. I mean, Unity as a game engine is really not a single. It's a collection of assets that have some links together that is magically done by the engine itself. So it was kind of interesting work to try to retain some hierarchy and coherency and put it together into COLLADA. But COLLADA, the exporter exports pretty much everything, including the animation, the skinning, the textures, and so forth. So I just show you just the different options there. And you can copy the images, of course, decide where you want to put it. You can export the animations or not, and you can export cameras, lights, or light maps. It's interesting to let's put that on this stuff. It's interesting that if you actually try to export the lights, you may have an issue when you import the COLLADA file because most COLLADA viewer limiting the number of lights you can display. They may pick like the first 5 lights, and then maybe hundreds of lights in Unity, and you may just have one room that's lit and everything else is dark. So usually exporting without the lights, if you just want to look at the model, is the best way to go. What's very interesting about Mac, despite the fact that I don't know how to use it, is the fact that you can actually go to the desktop where the file should be. I can find the desktop somewhere. Right, and then, nice looking desktop. So, and then that's not the file, just exported. Okay, and in the Mac, they already COLLADA is part of the OS. So if you just double click on it on a COLLADA file, it will just display it as a 3D object. But like if you click on it. Just like clicking a picture, so format for it's good media format on Mac. It does also have support for animation, and so all the animations are in Unity object and exported. So it's a nice way for somebody working in Unity, for example, to send an object back to some other people saying, hey, this is the asset I have, this is the way it's animated, what do you think of it? And you can send that to somebody that doesn't need to have Unity. You just click on the object and look at it. It's pretty complex and free to explore to save a Unity game and send it over to somebody's lot of files, so that makes it a lot simpler. I'm not gonna. No, I mean, I have. What is it? I need to find my slides now because I tried the Explorer in many different ways, and you can actually once you have that. Oh yeah, one thing I want to talk about pretty quickly on the technical side. One thing I wanted to do. I didn't know anything about Unity or C#, and I said, okay, well, I'm going to use the power of XML schema to directly use one of the tools to create an API for me to get to COLLADA, which is what XML was supposed to do for me. But I found out there's a bug in Microsoft XSD tool from like 2007 or something like that that has never been fixed. What I did is actually took the schema and I changed it a little bit. So Microsoft Tools that doesn't trigger the bug in the Microsoft Tools, and we uploaded that modified schema on the Khronos website. So now you can take that schema here and run it through Microsoft Tools, and you can generate a C++, a C#, a JavaScript, whatever API to import and export the document. So I thought it was a nice thing to do. Let's see. So then, you take your COLLADA and of course you can import it back into a DCC tool like Max or your own imaging or your veggie engine or Google Earth and put a little robot on top of the Unity headquarters. But Photoshop, in Photoshop it's interesting because you have access to the hierarchy. So, for example, when you export the little robot, it comes with this shadow, so you can click on the shadow and move it. So you only take your 3D model, rotate it, and then include that into whatever images you want to do with Photoshop. That's CS4. I've heard that in CS6 is much better. You can import the entire scene in SketchUp, for example, to go from the world of gaming into the world of CAD and more industrial. That SketchUp kind of bridge the two. No problem at all. You've got all your texture. There's no animation in SketchUp, but everything else is there. And then what else you can import into any other COLLADA viewer. So there you go. So that's the entire demo. Now you can put that Explorer and take any Unity content and then bring it to somewhere else. Thanks to COLLADA.
Good afternoon, everyone. Thanks for coming by. It's exciting to see all the new faces. My name is Uli Klumpp with Microsoft. I'm going to give you a very quick presentation that, in a way, is following up on Remi's. When he told me about his crazy idea, it actually reminded me of an interesting thing that happened to us a couple months ago. And that led to the title of this presentation, How Machinima Evolves, and how we think that maybe COLLADA and our puzzle product could help with that. Puzzle's been around for a long time. I'll move off the slide very quickly. The one thing that's kind of interesting is the bottom line here. We're enabling people to tell their story for a very long time, since '95. And that's really what this is about, I'm going to talk about next. We did find out relatively recently that one of the most popular creators of Machinima are actually using our puzzle product instead of just the game engine as the genre normally implies. And we went to they have a conference just like Siggraph, it's called Rooster Teeth Expo. And they explained how they use Poser to create these videos. And the interesting thing is, they have like 1 billion clicks on 1 billion views on YouTube, and they have DVDs shipping at Amazon and Best Buy and whatnot of their series, and they're using our tool. So that combined with what Remi came up with really led to this interesting observation that they're moving beyond just the game engine. They're reaching out to more traditional DCC tools for various reasons. Obviously, the assets need to be exported from the game engine or the authoring tools. You have to import them. You might want to blend additional mocap data that wasn't part of the game because you're telling a certain story that might or might not fit with what was present in the game. There might be hand animation that you want to do, or it might be
maybe behavioral data that the tool can generate for you. Some are looking for just higher output quality or distributed network rendering. That's the recently folks, they're using our distributed rendering solution for that. You can add in surface scattering, motion blur, depth of field, all kinds of effects. Now, that is coming, obviously, in the game engines as well. If you've been to the real-time rendering advancements session this morning, you'll see that all of these are coming now for the game engines as well, but they might not be quite there yet in your engine of choice, and I think it's fair to postulate that the CCC tool is always going to have some kind of edge over the game engine just because there's different priorities there. Or you might want to return it to the tool chain for further processing or put it out on the web, or we've heard about iBook's author earlier on. If you want to take game assets into an iBook, for example, this is a great opportunity, or something that we've been seeing. We just had our booth, an artist visiting, Brian Habel, and he made this incredible graphic novel, coffee table book, 300 plus pages with AR overlaying over it, and then there's a separate kind of interactive game / app that comes with it that allows it to relive those scenes. So if someone wants to create a story out of a game and present that, fitting into the tool chain is pretty important as well. That's not exactly easy. I know there's definitely a lot of challenges for the red versus blue guys. And we think that going forward, COLLADA can help with making that a little bit easier. There's a lot of different data that needs to be transferred. So what we're working on right now, this is not shipping yet, I just wanted to give you a preview a little bit. What we're trying to do is, we're trying to improve our import. So far we were very focused on exporting things. We perceived our place in the tool chain further upstream, and now we realize that we might be further downstream than we actually thought we were. So what's going on is that we're trying to import bending figures and also animation data so that then the tools within our product could be leveraged. And I just wanted to show a little recording of how this will look like going forward. So essentially, we're going ahead and importing. We're going to import actually the assets that Remi exported from Unity, so you'll see some of the same things again. Choose to bring the lights and cameras, that's optional, and there's still some challenges going on. What you see here is not exactly looking like what Remi was showing. We're still doing performance testing on the import, so there's work to do. I just wanted to illustrate that. But really what we're interested in for the purpose of this session, I wanted to show a little bit what we can do with animation tools here. So we're going to proceed and hide all the assets that came in from the game, and we're just going to bring up the main player figure in here that had a skinned mesh and bones with it. So we're going to play with that figure a little bit. Once again, there's still room for improvement on the import. He kind of fell on his face on the way in. But the interesting thing is that we really can go ahead and already pose that figure in the software here. That's really how it all started, having a digital mannequin available that you can pose and draw off of as artistic reference, and now we're able to do that for game assets as well. The next thing I'm going to show is how to generate a walk for this figure. You might already have exactly the sequence that you need for your story present in the game, and then you might as well export it from there and use it directly. But if you don't, then there's a range of tools available to create things. I'm just going to generate a run here, but there could be different kind of walks, sneaking, silly walks if we want. I'm just going to apply a run to that figure real quick. Let's play that back. The figure runs. So that's not a sequence that was in the exported assets. That's just created on the fly with one of our animation tools. And I could go ahead and animate more by hand now. I did very little of that for the purpose of this presentation. the next thing I wanted to show is how to bring in some motion capture data. And again, this could be from the game, or this could be completely unrelated motion capture data. In this particular case, I chose something very unrelated. Let's just bring that in and kind of put it just at the end of the walk to show you how these things can be easily blended. Anyway, so motion capture data is in. Let's try and play that back. So if the story that you're trying to tell involves things that are kind of out of character for the game, this is really how it's greatly facilitated by tools like ours. And again, the idea is that we're fitting into a tool chain, so we don't actually want to end this here. We could do it like the Red versus Blue folks and just send it to our network render queue and spool out the individual scenes there. But for the purpose of this session, I thought it was more interesting to actually export it out again to COLLADA and take it into a web browser so that we have a little bit of an idea how it would look like if these assets go out to the web. Export is done, and we're loading in a JavaScript-based viewer app in Chrome here, and once again you see the walk or the run, and then you see the dancing figure. This is all fully interactive, of course. So now we've taken the asset, brought in new animation, and exported it out again, so it can be embedded in whatever kind of web presentation you might want to have there. Good. That pretty much concludes my talk. If there's any questions or comments, I'd be happy to take them. I think we'll have a little Q&A session at the end, right? So maybe we'll hold it for that. And other than that, thank you, Arnaud.
Okay, I'll do a real quick demo of SceneKit, the Apple framework on OS X to import, render, and manipulate COLLADA files. I have to reboot on Mountain Lion. So you will see two things. The Xcode integration that Apple did to very easily integrate COLLADA assets in your application, and also a very, very quick view of the API to create a scene and do something very in line with the other Apple API, like core animation, but using COLLADA files. So we will begin with what's the hello world of COLLADA, which is the duck, if I'm not wrong. So I just dropped the folder in Xcode. Is it already? Here I clicked on the DA file and Xcode renders it straight away. And we can zoom a bit. The screen resolution is a bit teeny, so. Okay, I have my duck. And here I see, just by clicking on it, all the properties. And you can change these properties. For instance, if I want to change this paper, here we go. It's a bit saturated here. And you know all this stuff, but after you can save a new version of the COLLADA file. So what it enables you to do is to tweak a bit your scene at the very end before integrating into your application if you wish to. And then you can do other stuff, because you could just with a single line of code import a scene and render it and do pretty much what you do with a preview or playthrough for the one who are familiar, like having a viewer very easily. But you can also programmatically build the scene from scratch. So, for instance, I have this nice rock given by Remi. And this is a single mesh in the scene. And what I do programmatically here is I load this scene and extract that mesh and also create a camera and a light, just because I wanted to do everything with the API. But it could be also set up with the COLLADA file. But then you can, for the one familiar with iPhone programming, for instance, or even OSM programming, use the same API. For instance, core animation. You can use a core animation object, like see a basic animation, to change the position, but you can also use implicit animations to change the opacity of objects. So here I will just set random position to that asteroid and change the values both implicitly and explicitly with different kind of animations here for the one more familiar with the Apple API. And it's like 100 lines of code. It could be even less, I guess. And here we go. We have a very simple asteroid field, but you don't need to worry about COLLADA details or OpenGL detail. You just display 3D pretty much the way you would do for images with the core animation in the past. And that's it. Yeah. Okay, that's SceneKit on Mountain Lion.
Hello, my name is Christian Solz from the German Research Institute for Artificial Intelligence, and I will talk a little bit about the integration of COLLADA and XML3D. So XML3D, to make it really short, we are heading out of time here, is, well, I should make it a little better, is to integrate 3D into the HTML DOM. So we use the DOM as our scene graph. And this has the advantage that the millions of web developers can easily create 3D applications. That's the whole idea. It's a decorative approach. And we have a W3C community group where we try to standardize this together, for example, with Fraunhofer's X3 DOM. They have a quite similar approach like we have. And of course, we have a WebGL JavaScript implementation and an emulator of our ideas in the form of a JavaScript library. So if I have COLLADA as assets, why should I use XML3D? Well, COLLADA has no runtime, has no interaction capabilities, and so both approaches really nice integrate. You could use XML3D as kind of interaction framework for your COLLADA assets. And that's what we are aiming to. And we have a kind of nice COLLADA converter. I will show some results soon. Also, I had a really good discussion with Fabrice how we could use the efficient representation of COLLADA to JSON representation to link COLLADA assets inside the HTML DOM and use, so combine the best of both worlds. Well, for our COLLADA exporter, we actually did something similar to what Remi did. We used the XML schema and we generated a representation in eCore, which is the base format of the Eclipse modeling framework. And so we had a really nice Java data structure for COLLADA, and you can use it. So The nice thing is that you have dozens of tools around EMF, and you can use these data structures to generate editors. There are huge frameworks to give additional validation possibilities. You can connect it to databases and so on. And we have this COLLADA eco is available, so everyone who is interested in processing COLLADA with Java should have a look into this project. Based on this project, we did a COLLADA converter. We did the same thing for XML3D, where we have an XML schema, so we could generate a data structure for XML3D, and so it was kind of easy to create a COLLADA converter. Of course, we don't support the whole COLLADA set, I guess no one does, but we are in a good way, so we support dry nodes and polylist and instancing, all the standard materials, but also skinning, and we use our Xflow approach for that. I will talk about this later at the web tutorial a little more in detail. And we will publish this converter mid-September. So I will show some results. Well, I have to show this one here because, well, it's the hello world. So we export the COLLADA DAC, and the nice thing is there's now a simple on-click event on this. So, well, I can click on it and I have a hello world alert here. So it's really easy to add now functionality and interaction to it. And of course you can do more complex things. And so, so this is a scene that falls more or less like it is out of our COLLADA converter. The only thing we have to add is the logic of the animation and all the interaction, and also of course the camera navigation. I use a gamepad for that. There's a gamepad API in Chrome, so you can just navigate through the museum, and to see we exported this, including specular maps and normal maps and tangents, all the essentials we need to do nice rendering and spinning and animation here. Well, that's not really walking around. So, and all this runs in WebGL on CPU now. Well, that's essentially it. Maybe a little bit about the pipeline. We use just the scene was modeled in 3ds Max, and we used the open COLLADA plugin, which provides a really good COLLADA style, and we then converted to XML3D, and that's the result. Thank you.